Yes, hello viewer, I am still your teacher Osbert in Warinda. Now, in the previous video, I had told you that we are supposed to be going to the next episode, and that is none other than electron transport chain. However, as I was moving somewhere, a friend around asked me a question and was like, yes teacher, yeah, thank you for teaching and so on. However, I have an inquiry. Then I was like, you know what, go on, what's the inquiry about? He was like, yeah teacher, you see, you have given us all those charts and simplified versions of how to describe the Krebs cycle, the electron transport system and so on. And then he was like, now when I have that chart of mine there, how I assume it comes in a question, how do I write all those things in words? Do I just draw a chart? Do I have to put all those things in writing? Okay, if I'm to put them into writing, how exactly do I do it? And then it's from there that I felt that before we can go to the next episode, which is about electron transport chain. Let me first answer that question. Now, I want to make myself very clear. And what is this? I want to say that we really don't teach people to just pass for the sake of passing exams. Yeah, we don't just teach people for the sake of passing exams. I think that is from a wrong angle. However, we teach, or I teach, to enable you understand these basics. Yeah, these basics of the biochemistry. Some of you who are watching me, especially those ones who are in A-level, advanced level, this is the starting point. For some of you are going to be pharmacologists, pharmacists and so on. You need this basic science, you need this basic biochemistry. It is from this that where you add on more information when you have gone to campus. So I want to make myself clear that yes, I'm teaching this, but I'm not necessarily teaching it for the sake of passing exams. So in fact, you can go in an exam and you don't find any of this, because an exam is having very many other things to ask. So you can go in a final exam that you might be, depending on the level you are on, and then you don't find this. But you knowing this is very good for you to upgrade your studies depending on the course you are on. However, still, I will answer my friend. Now, even if this one was to come in an exam, its answering is very simple. For example, this is the part of Krebs cycle, and then with its connection with the link reaction. So here is our Krebs cycle. Now, if you have this in your mind, and somebody is trying to ask you, how can you put this one into words? For example, let me first answer that question. If I have something like this and somebody is asking me to put it in writing, I know, for example, from pyruvate to acetyl acetyl group, what I'm seeing there is the dehydrogenation. Why? Because this NAD plus is picking hydrogen from this reaction, which is involving pyruvate, for it turn to NADH. You get? So for example, let me first write the process here. This is dehydrogenation. This is dehydrogenation, for example. This is dehydrogenation. Of course, here we are also having loss of carbon dioxide. So that one I can call it decarboxylation. Can call this one decarboxylation, for example. Decarboxylation. And then here we have addition of a CoA. So that one I may not have a real process I can give, but we're having the CoA being added there. What we're having here is what? And when you check, what we're having there is this is dehydrogenation still. This is still dehydrogenation. Here we have decarboxylation. Are you seeing decarboxylation? Here we have dehydrogenation again. Dehydrogenation. We have decarboxylation here. Decarboxylation. We have, of course, here we are moving an inorganic phosphate to form ATP, adding it on what? Adding it on ADP. So this one here we can call this one here. This one is dephosphorylation. This is dephosphorylation. Why? We are moving the phosphate, adding it to ADP to form our ATP. And then here we're having this one as our dehydrogenation. However, what is doing the dehydrogenation here is a different molecule compared to what was doing dehydrogenation here. Of course, I told this is hydration, and then here we have dehydrogenation, hydrogenation again. So somebody can decide to make this one very simple, and they say that, for example, pyruvate, a 3-carbon pyruvate, a 3-carbon molecule, a 3-carbon compound undergoes dehydrogenation and decarboxylation to form an acetyl group, which then combines with the coenzyme to form what we call acetyl coenzyme A, in what we call in a chain, in a link reaction. We said all of this reaction here was called a link reaction. Assume you are from describing glycolysis and you have gotten pyruvate. Then now you are trying to connect to Krebs cycle. Then you will say that the pyruvate then moves from the cytoplasm into the matrix of mitochondria, under which it undergoes a link reaction. In this link reaction, we are saying the pyruvate undergoes dehydrogenation and then decarboxylation to form an acetyl group, after which the acetyl group combines with the CoA to form acetyl CoA. Then after, from there, you now come and say that now this CoA, this acetyl CoA then enters into the Krebs cycle by combining with the 4-carbon molecule, which is oxalic acid, and then form a 6-carbon molecule, which is called citrate. All together. Then from there, you say the citrate then undergoes dehydrogenation by NAD. Yeah, you can also tell us what is causing dehydrogenation. It is undergoing dehydrogenation by NAD+, and it is also undergoing decarboxylation. It is undergoing also decarboxylation to form alpha ketoglutarate, and then a 5-carbon molecule. Then alpha ketoglutarate then undergoes dehydrogenation by NAD+. Still, it undergoes dephosphorylation by ADP. ADP is the one which is causing dephosphorylation, and again it's also going decarboxylation to finally form a 4-carbon molecule known as succinate. Okay? Then we are now saying the succinate undergoes dehydrogenation once more, but now by FAD+. Then this dehydrogenation by FAD+ makes it form fumarate. All together. Then we are saying fumarate then undergoes hydration to form malate, which undergoes dehydrogenation by NAD+ to form oxalic acid. Then you can put a statement, and then you say after getting oxalic acid, then the cycle is repeated. And then you can put a full stop there, and then you say that whenever dehydrogenation is done by NAD+, then NAD+ is turned into NADH. And whenever dehydrogenation is done by FAD+, then the FAD+ is turned into FADH2. Now, dephosphorylation by ADP as alpha ketoglutarate is turning into succinate, results in formation of ATP. Are you seeing? It is formation of ATP. As simple as that. Now, I want you to take note here. For example, having taken you through how you can describe in a simple way. Now, I also want to caution you that you see, this that I've given you here is just a simple version of how you can understand this Krebs cycle. But I'm saying that as you read different books, as you're going to reading different books, I want to assure you that you're going to find there other ways, or even how you may find that they have even made this cycle you have here even more simplified. For example, are you seeing the way it is here? For example, somebody can decide to say that pyruvate, which is a 3-carbon, when you look at this chain here, you have pyruvate is turning into acetyl group, then from there it turns into coenzyme A. Now, somebody can decide first to remove this intermediate here, this middle molecule here. So you may read somewhere, you may be reading a book somewhere, and then you find when they have done it like this, that they have gotten they have said pyruvate undergoes dehydrogenation by NAD+, undergoes decarboxylation, and at the same time combines with acetyl-CoA to form a 2-carbon molecule known as acetyl-CoA enzyme A. In other words, they have eliminated the whole of this, the whole of this molecule. It is not there. They have just, for example, assume I come here and I draw an arrow, which is just like this. You may reach somewhere, and you're reading somewhere, and then you find when they have put something like that, something like that. And then when you find something which is like that, you don't now say that that is wrong. No, it is still correct. Why? Because what I'm saying here is that I'm having pyruvate. Within this series of reaction, I will have dehydrogenation, I will have decarboxylation, and then I will also have addition of acetyl-CoA enzyme A, and finally I will end up having my acetyl-CoA. So you may be reading somewhere, a textbook somewhere, and you find when they have put that. That is also correct. When you look at it in detail, it is also correct. Just the other one I had tried to break it a bit for you so that you can easily get it, but it is also correct. The other time I was telling you that you can be reading somewhere and then you find when they are given another molecule that from alpha ketoglutarate to succinate, there is another molecule which is formed in between here. I remember giving a research an assignment to get to determine which molecule here. So you may find when they have put that intermediate there, but you may read another book when they have not put it there, they have removed it like the way I've done it here. I've just gone straight to the final product here, which is a 4-carbon molecule. You straight the final product you get, but you may read somewhere and then you find when they have put that. So it means for me here I've summarized everything. For example, instead of putting that intermediate molecule, I've said get alpha ketoglutarate, have it undergo dehydrogenation, have it undergo decarboxylation, have it undergo dephosphorylation. The final product you get, ignoring all those intermediates, you end up having the final product as succinate. You get? Just like the way somebody can come and say, when you get pyruvate and add NAD+, you remove carbon dioxide, you remove the carbon in the form of carbon dioxide, what you have called decarboxylation, and then you add acetyl-CoA enzyme A. You add coenzyme A. The final product you get is acetyl-CoA, without first taking you into this acetyl group. That is also correct. So as you get this basic, I want you to be cautious that yes, depending on the book or of advanced level that you are reading, you may find when this one has been a little bit, it's not exactly the same as this, but we are saying as long as it's an official book, it's an official textbook, whatever you find there is always usually correct. Just that maybe some of these steps may not be it may not be having all those steps in detail as maybe I've shown you here, or it might be having some other details that I may not have shown you here. So this is the basic from where you can also build on. I don't think that I'm having friends here who are following me and the only thing they do is only to watch my video and stop there. No, I don't really advise that. You watch, after, go open textbook and read more. Enrich yourself more. I think that would make you a very good student than just only watching and you stop there. Then, for example, also as I come to the end, another person you may read somewhere and you find that you see this was 4-carbon. You see this is a 4-carbon compound. It is combining with a 2-carbon compound and forming a 6-carbon. From 6-carbon to 5-carbon, that is a key stage, and therefore you can indicate it. And then from 5-carbon to 4-carbon molecule to 4-carbon molecule, set also another key step, and therefore we need to show it like the way you see it here. However, I want to tell you that from here, when you check succinate, here we're having 4-carbon. When you see fumarate, you're having 4-carbon. When you check malate, you're having 4-carbon. You're having oxalic acid, also 4 carbons. Somebody can say, since I'm having here, the molecules are all having 4-carbon. That when you check what is happening there to them, the basic molecule, the molecules are almost remaining the same with the same carbon atoms. What somebody can do, you may go in a textbook, and then you find when they have put succinate here, and then they have put one big arrow, and they have come to oxaloacetic acid. Are we together? You may go in a book and you find when they have put succinate, then from here they put a very big arrow, and then they bring it straight what? Oxaloacetic acid. And then all these, the FAD plus, the water, the NAD plus are all attached onto that arrow. You see? From succinate, put a big arrow and it brings it right away to oxaloacetic acid. And then all these things, when all these things have been attached onto that long arrow, still, when you find something like that, no, you don't complain that, how come this one is different from what Josephat has been teaching me? No. That in that way, if you have succinate and you are adding all these things here, and you are coming to oxaloacetic acid, that is all correct. Just that now, that author of that textbook would not have wanted to just go into all these details, but for me, I have broken them down for you to get somehow a little bit deeper. You get? However, I want to tell you that if as you go further, as you read ahead, as you advance in your studies, even this one here, you may find other more details within this reaction that I'm putting here, which seem to be few. You may find even further other more reactions within them, but that one will come as you advance your studies. So, bottom line, this that I'm giving you is just the basic. After you have mastered that basic, I want to assure you that you can be able to answer any scenario that can come when you read it and interpret it. You realize that it is requiring you to describe the process by which energy is produced within that organism. You can be able to do that very well if you have understood this basic. Are we together? So I want to advise you that please just get to know the basic, and then putting it in words together. I think that one you can easily be able to do it after you have learned the basic, because I've told you just here, for example, from citrate to alpha ketoglutarate, just simply say that citrate undergoes dehydrogenation by NAD plus, and also undergoes decarboxylation. Then forms alpha ketoglutarate. You can even add immediately there, and you say during dehydrogenation, NADH is produced, and during decarboxylation, carbon dioxide is produced. Then you now come and say alpha ketoglutarate is then undergoes dehydrogenation, dephosphorylation, and decarboxylation to form succinate for carbon molecule. Then you now say from there you add something that during decarboxylation, carbon dioxide molecule is produced. During dehydrogenation, ATP is produced, and during dehydrogenation by NADH is produced. And then you continue like that until you now come and reach and you say now the cycle is repeated. Are we together? Yeah, so that's how you are supposed to describe. So I hope you have understood me. So with this basic, I think now we are free. We can now be able to confidently head onto the electron transport chain. Please, you don't need to miss this. Let me meet you there. May God bless you.